Good afternoon. Good afternoon. Hope all is well. Hope everybody's doing all right. Sorry about that. I did not expect that phone call, but uh, it's everything's okay. So I appreciate you guys holding on and being patient. I really do. All right. Before we get into anything that I'm going to remember, I know we talked about going into chapter 8. Anybody have any general questions or concerns that they wanted to run through? Is everybody all right? Everybody good?
So the class in the 18th, and when do we have the final?
The final is the 13th, that Wednesday before. The 13th, yes. So the final will be on the 13th, and then I'll give you to the 18th to be able to submit all of your stuff in Math Lab, whatever.
Okay.
All right. Anything else? Anybody else? Everybody good? All right. So the notes will be a little different today because I actually wrote these out and I tried to write them on the other screen, but my students at the time was like, they should have shown me what you had, and they said this was good enough. So this is 8.1, distribution of the sample mean. And I can make it larger. That'll help. So we're looking at just talking about 8.1 and 8.2 today.
Which day will be the last day of like all our notes and everything?
Say that again now.
Which day will be the last day for all of our notes?
You said which day?
Yes.
Well, I know we got to do 10.1 and 10.2 as well. So I'm thinking, let me look. Yeah, 10.1, 10.2 then.
You said we're in 8, right?
Say it again.
So this is 8.1.
Yeah, we're gonna do 8.1 and 8.2 today. And then we have 10.1 and 10.2 that's left as far as new lecture material. So we
Okay,
can do
9 in between or nothing like that.
no, because there was a section in chapter 9, but what I do is just incorporate that discussion in chapter 10's content. So we don't have to include a whole nother homework section or anything like that. So I just pull what we need from chapter 9 and just talk about it in chapter 10.
Okay.
Yep. So let me see. We are looking at, if we do 10.1, 10.2 next class, and I don't add anything extra. Yeah, so that'll leave us actually with 3 days of, just open review for you guys to ask whatever you want. Unless instead of doing 10.1, 10.2 next class, we let that be an open day for review and then come back next Monday, do 10.1, 10.2. So, I mean, there's a couple different ways we can play with it, but we have some extra days, have some days with the way I taught it. We have some days in there as cushion in which, we can kind of play with. But mainly, the main thing is that we're doing 8.1, 8.2 today. And then after this, all we have left as far as new material is concerned is 10.1 and 10.2. So. All right, so this is 8.1, distribution of the sample mean. So the sampling distribution of a statistic is a probability distribution for all possible values of a statistic computed from a sample size of n. The sampling distribution of a sample mean x bar is the probability distribution of all possible values of the random variable x bar computed from a sample size n from a population with mean, mu, and standard deviation sigma. And all this stuff we just laying the foundation, but you'll see the process once we put some numbers on it, it all makes sense. But just laying that foundation right now. All right, can I scroll up? All right, so suppose that a simple random sample size n is drawn from a population with mean, mu, and standard deviation sigma. The sampling distribution, x bar has the mean. So, and we're going to use this. Let me see if it'll let me draw on it. Where's my draw? Oh no. Okay, it won't let me do it this way. Let me go back. Trying to get my this off. All right, so it won't let me do what I want to do. Okay, so basically, when we look for our mean for our sampling distribution, it's going to be the same thing as our population mean, and then we'll be able to calculate the standard deviation by taking the population standard deviation and placing that over the square root of the sample size. So like I said, once we put numbers on it, you can see the connection, but that's what that says right there. All right, can I scroll up? Of course, if I scroll up too far, make sure you let me know. So here it says standard deviation of the sampling distribution of X bar is called the standard error of the mean. So if they're talking about the standard error, that's the same thing as the standard deviation of your sampling distribution. And it says if a random variable X is normally distributed, the sampling distribution of the sample mean X bar is also normally distributed. And so if it's going to be normally distributed, that means we can use z-scores. So that's why that statement is important. All right, can I go to the next screen? Somebody's still copying. All right, let's go to the next one. All right, so let's look at this next one. Actual example says the IQ, calling that X of humans, is approximately normally distributed with mean being 100 and standard deviation being 15. Compute the probability that a simple random sample of size n equal to 10 results in a sample mean greater than 110. All right. So first thing is always good to write down the given information whenever dealing with a word problem. So the first thing they give us is that the population mean is 100. So I have it over here in this red box. Population mean is 100. The mean of the standard deviation of the population is 15. Our sample size, lowercase n, is 10. And the value in question, the sample, what we're comparing it to, we want to know if the sample mean is going to be greater than 110. So that X bar is going to be 110. So that's where how we assign our numbers to our symbols. All right. So according to the relationships that we just finished mentioning, the mean of our sampling distribution, and let me do this because I want to be able to write on this. So right here, the mean of my sampling distribution, notice how we got that. That is equal to the population mean. That's why that is 100. Right here, the standard deviation of my sampling distribution is the population standard deviation over the square root of our sample size. So we got 15 over the square root of 10. All right, any problems with this part, what we did? Remember that came from the relationship that we established in the previous page. All right. So once you've done that, we can find our z-score. And we'll use this relationship right here. X bar minus the mean of the sampling distribution divided by the standard deviation of the sampling distribution. And that gives us 2.11. All right. So once you have your z-score, you can go to the z-score chart. And if this is too far away, you need me to magnify, please let me know. But I was trying to write on the screen a little bit to show my emphasis. When we go to the chart, we should get 0.9826. All right. Now don't forget, our chart will always give us less than, but we want greater than. So remember, if we want greater than, you always take that value and subtract it from 1. And that gives us 0.0174. All right, so then we have that concluding statement right there, the probability of obtaining a sample mean IQ greater than 110 from a population whose mean is 100 is 0.0174. All right, any problems? All right, can I go to the next page? Somebody still copying. All right. All right, next page, central limit theorem. Says regardless of the shape of the underlying population, the sampling distribution of X bar becomes approximately normal. Remember, being approximately normal is what we need to do z-scores as the sample size n increases. All right, so if you increase your sample size, it should be approximately normal, or we can assume that is approximately normal. And once again, that assumption is necessary so that we can use our z-score chart. So if the distribution is approximately, if the distribution of the population is unknown or not normal, then the distribution of the sample mean is approximately normal, provided that the sample size is greater than or equal to 30. So we're looking for 30 as our magic number for our sample size. So we want it to be greater than or equal to 30. Mhm. All right, so here the mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right, and obstetrician obtains a random sample of 35 low-income patients and determines their mean weight gain during pregnancy was 36.2 pounds. Does this result suggest anything unusual? All right, can we go to the next page? Anybody still copying?
I'm still copying.
Okay, not a problem. Take your time.
All right, I'm good. Thank you.
Not a problem. Not a problem. Anybody else before we go to the next page? All right, so we're going to take the information that we had from that last problem and perform the task. So you see in my red box to the left, the mean of the population is 30, standard deviation 12.9, sample size is 35. He took 35 low income patients, and then the mean that was in question 36.2. So I just, yep, yeah. So we see right here, we find our mean. There we go. The mean of our sampling distribution is 30. Standard deviation of our sampling distribution, 12.9 over the square root of 35, which is 2.180498. And of course, you don't have to go out that many spots. I go about maybe about 4 or 5, maybe 6 sometimes just during my calculation. But when I get my final answer, I only go those 2 spots. But the further you go out in your calculation, the more accurate your answers will be. So once you have those 2 pieces established, you go ahead to find your z-score. So we do 36.2 minus 30 over that 2.180498. And don't forget, z-scores always round to 2 decimal places. And then we hit the chart. All right, that's 0.9977. So don't forget, once again, whenever you get that chart value, that represents less than. Right, can I screw up? All right. So here, since we want to know how unusual this is, then we want to know the chance of it being greater than, or the chance of being greater than. So now if we want to know the chance of being greater than, remember that means we take our chart value, subtract it from 1, and that gives me 0.0023. That is our answer, and this is unusual because the probability is less than 5%. Remember that was our marker, 5%. If anything is less than 5%, then it is considered unusual. All right, everybody good? All right, anybody still copying? Very good. All right, just making sure this is the same as 4. Just make sure I didn't miss one. Yeah. So those types of problems, that same process is the process that's emphasized in 8.1. You take either mean, population, sample size, and then they give you the X bar. And then you convert it like we just finished talking. Where my pen at? Then you convert it using these relationships right here. Once you have those 2 pieces established, z-score, from the z-score, go to z-score chart, and then find your conclusion. So that's the process in 8.1. 8.2 is very similar, and just a few different symbols, but it's very similar. So we'll see that now. So this is 8.2, distribution of the sample proportion. Magnify it some. No. All right. So distribution of the sample proportion. Once again, this is 8.2. Suppose that a random sample of size n is obtained from population in which each individual either does or does not have a certain characteristic. The sample proportion is given by p hat, just x over n. And where x is the number of individuals in the sample with that specified characteristic. And then the sample proportion is the statistic that estimates the population proportion. So we already know the n is, the sample size. But as before, laying the foundation, once you put some numbers on it, hopefully it'll feel better. When you see P, that's going to represent our population proportion. P hat, our sample proportion. All right, we done with this page. All right. So not a full problem, but this is just one of just focusing on making sure we understand how to compute the sample proportion, P hat. So the Harris poll conducts a survey of 1,200 adult Americans who vacation during the summer and asks whether the individuals plan to work while on summer vacation. Of those surveyed, 552 indicated that they plan to work on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. I'll give you a chance to write it down. All right. So it says 1,200 adults or adult Americans were surveyed. So that's the number of our sample size, 1,200. Out of the 1,200, 552 had this characteristic of planning on working while on vacation. So 552 people fits this category. And so all you would do to find p hat, the sample proportion that references those who will work while on vacation, excuse me, is take 552 and place it over 1200, and that'll be 0.46. So if you had to make a statement from that, and your sample proportion is just an estimate for the population. So Harris Poll estimates that 0.46 or 46% of adult Americans who vacation during the summer plan to work while on vacation. So that's what the sample proportion, that's how you calculate a sample proportion, and that's what it's for. All right. Can we go to the next page? All right. All right. So sampling the distribution of p hat. For a simple random sample of size n with a population proportion of p, the shape of the normal distribution or the sampling distribution of p hat is approximately normal, provided that this condition is met. So we'll test that condition before we actually do the problem. You got to do n times p times 1 minus p, and it has to be greater than or equal to 10. And so if that condition is met, then that means it's approximately normal, which also means we can use our z-scores. So that's why we need to make sure that that condition is met so that we can use our z-score chart. And if that is the case, then the mean of the sampling distribution will be equal to whatever p is. And then the standard deviation will be equal to the square root of p times 1 minus p over n. All right, I scroll up. So according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. All right. Are we done with that standard deviation? All right. So in a random sample of 120 Americans, what is the probability at most 12% have hearing trouble? Suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. And then what might you conclude? All right. Everybody done copying? All right. So let's look at testing the condition to make sure we can actually go forward. So first thing you want to ask yourself, is the sampling distribution approximately normal? So we know N is 120. That's our sample size. And then the population proportion was 15%. Said 15% of all Americans have hearing trouble. So that's our P, 15%. So we do 120 times 0.15 times 1 minus 0.15, which would be 0.85. Multiply those together, you get 15.3. And that is greater than 10. So you see the last statement I read says since 15.3 is greater than or equal to 10, the sampling distribution is approximately normal. And that means that our z-scores can be used. All right. So we got p hat. They gave it to us in this one. And let me go back real quick, show you. So in this one, notice it says in A, a random sample of 120, that was in. What is the probability at most 12% have hearing trouble? So they gave us p hat in this case. So that's where we got that from. So 12% is that p hat. And then remember our relationship, the mean is going to be equal to p. So that's why that's 0.15. And then this little, I made a mistake right here over here, and that's not supposed to be there. I actually meant to change it and didn't. So forgot about that. But that, oh, that piece right here is not supposed to be there. That piece over in. So just throwing it out there. So let's go back. So that's what we're looking at. That's how we calculate our mean. Doing the square root of 0.15 times 1 minus 0.15 over 120. Once you have those 3 pieces established, then you can go ahead and plug it into your z-score. Very similar to what we did with the last one. This time our symbols are p hat, then the mean of a sampling population distribution, and then the standard deviation of it. What was the sample distribution? P hat. And then so it's 0.12 minus 0.15 time divided by 0.032596. And that'll end up giving us negative 0.92. All right. Can I scroll up? So we're looking at negative 0.92. Go to the chart. That gives us 0.1788. As before, that chart value is less than. So red statement, since the question asked at most, this means we want less than. So at most means the value that you have is the most, and then you talk about everything under that. So at most is less than. And so that's the value, that's the chart value. So that would be our answer. So the blue statement, the probability that a random sample of 120 Americans result in at most 12% having hearing trouble is 0.1788. All right, everybody good? Any questions? Can I go to the next page? Okay, so B, suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. So this time they didn't give us a percentage or a proportion, they give us the number. So 26 having hearing trouble, what might you include? All right, so let's go to B. So since they gave us 26 and not a percentage, we need to go ahead and convert that to a proportion. So you would do 26 over N, or 26 over 120, which is X over N, to get that population proportion, that P hat. And so that'll be 0.217. All right. Our mean and our standard deviation are the same because we're still dealing with the same problem. So that's 0.217 minus the 0.15 over 0.032596. And that gives us 2.06. Go to the chart, and that's 0.9803. All right, scrolling up. Okay, so since the question asks what might you conclude, we should explore greater than to see how unusual it is. Remember we talked about before, greater than, whenever you want to see how unusual something is, you will see, what's the chances of something being greater than it. So greater than, that means we will subtract that chart value from 1, 0.0197. And since it's less than 5%, 0.05, this means it is an unusual occurrence. Got another sheet. The results obtained are usual. All right, can we go to the next page? All right. So since we had it's unusual for this to occur, we can make one of two conclusions. The population proportion of Americans with hearing trouble who regularly listen to music using headphones is 0.15%. And we just so happen to randomly select a higher proportion that have hearing trouble. So in other words, it's a sample size. So basically what we're saying, we out of the people that we selected, we just so happen to select a lot of people that had hearing trouble. So that could be a possibility. You just choose stuff at random. So it is possible that majority of the people you chose did have hearing trouble. But then the other one, which is more reasonable, the population proportion of Americans with hearing trouble who regularly listen to music using headphones is more than 0.15. So, because they're using the headphones and they may be using them at a, louder volume that's safe, not as safe for your eardrums. That's probably the reason, because they're using those headphones. All right. I think that was it for that one. Any questions? Questions? So everybody done copying? Good. I think that was the last sheet. Yeah, the next sheet's going to chapter 10. So going back here. So if you look at how this is set up, it's very similar to what we did in the last section. Um, you have your p hat this time instead of x bar. You establish what your mean is and your standard deviation. Then you go through your z-scores. Then you go to the z-score chart. If you have any problems reading that z-score chart, make sure you get with me. What it was 2.06 here. So remember how we read that. Let me go back to it. Just remind you, if we have the 2.01, for 2.0 right here. Where am I draw? There we go. 2.0 right here. I think 2.06 and 6 is right here. And then you just go and look where they meet at. So every time I said I went to the chart, that's how I did that. The right digit is always up here, and then everything before it is always over here. And then you draw your conclusion accordingly based on whether it's less than or greater than unusual and so on. So looking at most, math lab and where you guys are, most of you are in a good place. But for those of you who are a little behind, make sure you pick up the pace because like your classmate mentioned in the beginning of the class, the end of class is October 18th. And, that's less than a month away. So we're looking at really just, 2 weeks. After this week, we only have 2 weeks left. And to get all of that math lab work in. And so I know that we have, a lot of content to cover. So I didn't try to add stuff. So I tried to give you guys, as, I won't say the least amount possible, but you know what I mean? Not trying to overwhelm you guys with a whole bunch of stuff. So we got 8-1, yeah. So most everybody needed to jump into chapter 7. Just trying to see where everybody is and everything. But yeah, so questions, concerns, comments, anything, anybody?
So it's a little, I mean, ahead of ourselves, but for the final, I know it's proctored, correct?
Yes.
Is it during the same class time or is there a different time frame that we're taking the final?
Nope, it's the same class time, same Zoom link and everything. All things, and I'm gonna send you guys an email out, just laying it all out. What I'm gonna say to you verbally, like right now. It's the same thing, it's just that when you come in, you have to make your camera enable your camera. Um, just the only time that I ask that you enable your cameras during this proctor final exam. Make sure you bring your ID. So what you would do is you'll come in, show your ID to the camera, and then stay logged on. I gotta say that too because I've had people in the past that as soon as they got the password, they just tip on out, and I'm just like, what was the purpose? It coming through. So yeah, so let me see what those. Okay, there was something else. Yeah, so you come in, make sure your cameras are enabled, leave your cameras on, show your ID, and then you just take the test. And then when you're done, you can log off. If you have any questions, feel free to, if something happening with Math Lab, let me know. I'll be right here. And as soon as you're done, you can go check on out. If you have any questions about anything, of course you can ask. But yep, that'll pretty much be it.
Perfect, thank you.
Yep, not a problem, not a problem. Thank you for asking. And like we mentioned before, that'll be on the 13th. So that will give room for, remember I told you that if you didn't do as well as you like, I am going to make it so that we have a final exam makeup opportunity, which you would do that on your own. But so that's why we have to take the final exam on that Wednesday, because if I do it on the 18th, that opportunity is not going to be available because I got to get grades in the next day. So that's why we're taking our final exam on the 13th, so that that final exam makeup will be an opportunity or an option for anybody that want to take advantage of that. Let's see, anything else? I think that's pretty much it. Any other questions, concerns, comments, anything, anybody? So I just want to make sure that you guys, I think we talked about it. You guys saw the video I sent out. I know I'm letting class out early. I don't want to get in trouble with anybody. If you got anything you want to talk about right now, this time is here. So I don't know what else to say other than going into chapter 10. And I'm pretty sure y'all don't want to go into chapter 10. So I'm just making sure that everybody's good before I close this session. Okay, you're gonna be emailing me? Cool. Not a problem. Not a problem at all. So, and yeah, everybody good before I close out? Everybody straight. Okay.
Okay.
Appreciate you, sir. Appreciate it. So also let me say this before we close out as well. Let me say before we close out. On those days, we're going to have some days that we're not going to do anything or any new material. That will be the opportunity for you guys to ask whatever you want from the beginning all the way up to chapter 10. You can bring those questions. It'll just be a free day that you can ask whatever questions you want. If you want to come in and ask questions, that'll be great. If you don't, they're not mandatory. I'm not going to make you come here and listen to other people's questions if you don't have any and you don't feel like listening to other people's questions. So after we cover chapter 10, the next day that I have to see you will be the 13th, which is final exam day. So those review days, up to you if you're going to show up or not. And I'll just handle them accordingly. I'll show up on time, be here, and then we'll go from there. All right. So you guys have a good one. Be safe, and I will see you on next class.
Thank you.
All
Hey,
right,
you take
thank you.
care.
Yeah,
You have
you
a
do the
nice
same.
day.
Thanks, do the same. Take care. Will you have a review, we go over together, or should we have questions? Okay, you said, will you have a review, we go over together, or should we have? Well, you can do we for each test and for the final exam, there's a test review. So what you can do, what you can do is look at each one of those test reviews and see if you have any questions off of those, and then we can just do them when you bring them to class.
All right. Thank you.
Yeah, not a problem.
Bye-bye.
Bye.
I gotta keep this.